So, hello, thank you for listening to me. So, my name is Scherezade, and I'm going to briefly talk about my thesis about low power class ablative pulse plasma thruster. As I'm close to defend, my supervisors have been Mario Merino and Jaume Navarro Caballé. And this is a new open live for our group, not just in terms of thruster itself, but in terms of being the first time working with pulse devices. So I'm not going to do a complete summary of my thesis, but just a brief recap focusing on the last year. So first of all, I'm going to brief introduce the motivation of the objectives and briefly the prototype itself, to later continue with the description of a consolidated work about two novel techniques that we are proposing to easy approach the 3D reconstruction of the plume with time resolution. So let's start about the working principle of PPT. What we have in the end are two electrodes that extend axially, defining a channel-like configuration, and they are connected to energy source and an energy storage unit. And at one end of the channel, what you have is a solid propellant. So once you have enough voltage on these electrodes, you trigger the discharge through a spark plug, and what you have is a flashover of the discharge along the discharge of the propellant. You have a fraction of it ablated and ionized due to these high currents, and the interaction of this current with the self-induced magnetic field accelerates this plasma down the channel. So the PPT, the ablative pulse plasma thruster, have as advantages for nanosatellites, the potential for being compact, and for the downscalability in terms of both powers and for power and size. So even in contrast to these advantages, the efficiency, people have to typically struggle with efficiency. So this is what justifies in our case that we have applied a more physics approach to the research much more than engineering itself. So after designing, developing, and verifying the reliability and repeatability of the chart, we have focused much more on plume studies. And about the plume studies, different preliminary works have been required that I've presented all of the different years. And finally, we have two, as I said, two techniques of convalidated work that they constitute a step in comparison to the current state of the art, because there are not so many studies about plumes in PPTs, and the ones that, especially on 2D expansion, and the ones that exist are limited typically in terms of results, or they require very much more complex setups. So we are presenting an option that you can carry out with a relatively simple setup based only on current measurements, ion saturation current measurements. So this is the first one, and we have recently published it in PhD. And what we have is we have reinterpreted the time of flight technique through ion saturation current measurements carried out by a single Lamouille probe extended axially along the plume, which are able, with the model that we present, to identify, isolate, and characterize the different ion population, assuming them as Maxwellian. So we provide, in comparison to the current state of the art, we managed to provide many other variables in addition to velocity as the divergence of the thermal spread. So what we see is, like in my case of my setup, of my prototype, I have typically three ion groups, and that we hypothesize them to be created, the first and the second one, at the same at the same time, but with a different charge and mass ratio, and the third one to be created as a secondary breakdown. The velocity slowed down with the larger is the number of the ion group, and the first one, it's about 50 kilometers per second. So we have carried out also a parametric study in terms of operational conditions around the nominal point, in terms of the capacitance and the discharge voltage. And what we have seen is like the velocity doesn't vary so much, and also that the total charge is linear with energy. This leads us to assume that the impulse speed is also linear with energy, as it has been widely presented in the literature with direct measurements. Also, what we see, it's like the second and the third ion groups, even that all of them increase their current with both voltage and capacitance, much more than voltage and capacitance. The second and the third one experience a relative higher growing with respect to the first one. And also we assume that within that energy range, the plasma composition doesn't change for my setup. So in the second case, this second technique is my current work, and this was in this we are addressing a more accurate description of the cross-section of the plume, and this was motivated by our limited results in terms of divergence, and also because in preliminary works we detected that we did not have a symmetric plume. So what we use for this is we have developed a proof-grid system in which you can reconstruct the current density distribution in terms of space along the cross section from the integral line measurements along the two representative cross directions of the plume. And what we use is to resolve the inverse problem. To define the density, the current density functions with a separate with variable separation. So we have seen that with our measurements that our plume is not symmetric, and the current tends to concentrate along the bottom and the right of the plane, and also that we have different poles along one of the direction, particularly the E1. The wild one, sorry. So to resolve the problem, like to get the current density distribution from the line integral measurements, we have applied a piecewise function scheme, and this is for the interval of interest. Oh. Okay. Like this is a video. This is what I want.
You have to do what?
This is a video of what I want to play. Well, yes.
No, click on the image itself.
Well, if not, we can talk. Okay. So what we can see, this is the evolution of the cross section along an interval of interest in which you can cap the peak points of the current of the three ion groups that I've mentioned before. And in the other two images, they are not space math, so be careful what they have. They are presented the cross-axis propagated in time. So what we see is, as I said before, that we have the plume, the current much more concentrated on the bottom side and slightly non-aligned with the central axis towards the right side, and also that we have two poles. Two poles also at the size of the central line. And finally, in the last plot, what you can see is like with this, we can get an estimate of, we can reconstruct the total current that is driven by the section. In that case, is represented with time. So finally, about my current work, well, I'm close to the end. So what I'm doing is working on reporting this work. The last one, like consolidated work about the cross-section description, and also to expand the previous model to the X and the Y direction. That's the plan. And after that, it's just continuing with the thesis writing and different So about the presentation, the conferences, this work has presented as main author in 6 in international conferences. For the moment, I have 2 publications in PQ1. The first one is it's about the work I did during my internship at the Japanese Space Agency on ECR and gridded ion sources and cathode using alternative propellants. That was my principal work there. And the other one has been recently published about the first technique I presented. And also now with this, we hope to get at least 1 publication. We'd like to. And about other contribution, we have an open research line coming from the first part of my thesis that it has not been the focus anymore, but we have an open research line on plasma modeling because we have it has been proved elusive to like the existence of a comprehensive local local model that describes the plasma for PPTs along all their stages. Such consistently. So we have that line open there, and also I guided together with Mario Merino the design of an impulsive thrust balance for PPT. With a final for the final project of the bachelor thesis of Guy. It has been supported by different projects, but mainly the Martin Lara and Regional 1, which was successfully closed last year. So thank you for listening.